moving on with our rational expressions. Well, now we're going into rational equations. And recall back from day one, lesson 1, the difference between an expression and an equation is the equal sign, right? In equations, we are actually solving. We're finding the value of x that makes both sides of the equation equal. In the expressions, what we did in lessons 16, 17, 18, we weren't doing that. Our final answer was a fraction or something reduced. We were just getting fractions, multiplying them into 1 or adding and subtracting them into one fraction and then trying to simplify or reduce it. Here, we're actually going to be solving. We're going to find x. All right, so start off here's the procedure for you. I'm not going to bore you by reading that, but you'll see how it works as we go through the example. All right, so example 1, pretty easy because we already have a common denominator of 9. Okay, so once you have a common denominator, it's simple as, okay, I'm basically multiplying both sides by 9 to get rid of that denominator. So if I multiply this side by 9 and multiply this side by 9, basically multiply every single term by 9, okay, the 9s are going to cancel out. Times 9, times 9, times 9. Now, you won't have to show this, but that's basically what happens when you get a common denominator. The denominators are going to cancel right out. You're just going to solve what's left over. So we don't actually have to show that starting with the next example. We're not going to be showing that. Anyways, the 9s just drop right out because the denominators are all the same. It's got to be across the entire equation. And we're left with just 2x plus 5 equals 8. And then subtract 5, you get 2x equals 3. And then x equals 2/3. Or I'm sorry, x equals 3 over 2. Now, example 2, we're getting right into uncommon denominators, which is pretty much what you're going to be seeing. So you're going to use the skills you learned in lesson 18, finding the common denominator, except you're going to go further with it. You're going to get rid of the denominators and then solve the equation. So it looks like this is a 2 times 3, so we're going to go times 3 here. And then here we're going to multiply by 2. And then we don't need to do anything to this one because we already have 5, 6. So we want a common denominator across the entire equation. Every fraction you want to have the same exact denominator. Both sides, everything. So now I have, watch, I have 3x. I'm going to go over here. I have 3x over 6 plus 2 over 6 equals 5 over 6. So I can combine this really, 3x plus 2 all over 6, that combines really to one fraction. So when I multiply by 6 on both sides, again I get my 1, and then this 6 goes to both really. It's really just, remember this is just one fraction, 3x plus 2 over 6, over just 1 6. So this 6 here we multiplied by really just cancels out. I shouldn't say cancels. It reduces this to 1, and then we get 3x plus 2 equals 5. Another basic equation, 3x equals 3, x equals 1. So there you go, x equals 1, and x can be 1 because there's no denominator with a variable. All right, so for example 3, we have, we have a 3x, a 4, and an x. All right, so our common denominator is going to be 12 because 3 and 4, the common denominator, the common multiple is 12. All right, and then x, so 12x. So how do I make 3x become 12x? I need to multiply by 4. How do I make 4 become 12x? I need to multiply by 3x. How do I make x become 12x? I need to multiply by 12. So whatever you do to the bottom, you have to do to the top. Whatever you do to the denominator, you have to do the same thing to the numerator. So I'm going to multiply by 12 up here, multiply by 3x up here, and multiply by 4 up here. All right, so now I have 16 over 12x plus 15 over 12x. I'm sorry, 15x over 12x equals 36 over 12x. Now see how I have 12x, 12x, 12x? By multiplying everything by 12x, that 12x is going to go away. we're going to get 16 plus 15x equals 36. So we're going to subtract 16. 15x equals 20. And then we're going to divide by 15. Okay, we're going to get x equals 20 over 15, which 5 divides into both of those, so we can reduce that to 4/3. We can reduce that to 4/3. So x equals 4/3. Okay, and for this equation, x cannot equal 0. X cannot be 0. That's an extraneous solution. All right. So how about here? You know what students like to do here? They like to go, oh, minus 2. Don't write this. Minus 2 minus 2. No. Absolutely not. You cannot subtract from a denominator. You can't subtract. You have to use the groups of factors. You have to multiply. You can only multiply. This is x minus 2. So you need an x minus 2 on the other fraction. This is an x. So you need an x over here. So what we're going to do is put an x over here and an x up there. We're going to need an x minus 2 over here. We're going to need an x minus 2 up here. So don't be fooled by saying, oh, I just subtract 2. No, you cannot subtract. You have to multiply. Use the groups of factors. All right, so here I have 3x minus 6. I'm going to distribute that right away. Over x minus 2 equals 8x x minus 2. So I have a common denominator. I'm left with 3x minus 6 equals 8x. Subtract 3x. Negative 6 equals 5x. Divide by 5. X equals negative 6/5. All right. All right, and for example 5, we have to factor. Looks like we have a plus 2, we have a minus 2, we have a squared minus 4. That can be factored. A plus 2, a minus 2. We should know our factoring by now, just like that. Should be very, very easy. A squared minus 4, you should look at that and be like, oh, that's a plus 2, a minus 2. All right, now we got to get a common denominator. Well, we already have a plus 2, a minus 2 here. I don't have to do anything over here. Let me get rid of this from example 3. Okay, so I don't need to do anything on the right side. But here I have an a plus 2. I need an a minus 2. I need to multiply by a minus 2. So the top needs to be multiplied by a minus 2. And then the bottom for this one, this middle fraction here, needs an a plus 2. So I'm going to multiply the top by a plus 2. And that's kind of how it works. So if you look at the denominators, a plus 2, a minus 2, a plus 2, a minus 2, a plus 2, a minus 2. Those are going to cancel right out. Boom, boom, boom. Okay, so the denominators cancel out. What are you left with? A minus 2 plus a plus 2 equals 4. So now I have 2a minus 2 plus 2 is a 0 pair. 2a equals 4. Divide by 2, a equals 2. So there it is. And the problem is here, a cannot equal 2. If you go back to your original, a cannot equal 2. A cannot equal 2. And a cannot equal negative 2. Because that would give us an extraneous, that would give us a 0 in the denominator. So therefore, if a cannot equal 2, I have no solution. So the way you write that is you just write braces, empty braces. That means the empty set or no solution. Example 6. So here we got, what's this? X minus 6 minus 2, right? Yep. And what's nice is I already have x minus 6, so I need x minus 2. I mean, I said that wrong, but you know what I mean. X minus 6. I need x minus 2 here. I need x minus 2 up here. So I have my common denominators. Boom, boom, boom. Gone. Here I have x minus 2 plus, now this x has to get multiplied by the x minus 6. That's x squared minus 6x, and that equals 4. Now look what I have. I have x squared. I have x minus 6x, which is negative 5x, minus 2 equals 4. I get it equal to 0 because I have a quadratic equation. I have x squared minus 5x minus 6 equals 0. Wow. So now I get a quadratic equation from my rational equation. That's okay. We know how to handle this. We've been solving these all year pretty much, right? We factor x minus 6x plus 1. And I get x equals 6, and I get x equals negative 1. But I have to check with my original, what can x not be? X can't be 6, and it can't be 2 based on my factors here in the denominator. So x can't be 6, so my solution is just negative 1. I have to reject the 6. That's a reject. 2 more. I put this one on here because it's a 1 minus x, and remember it's switched around from x minus 1. I think x minus 1 looks better, right? So let's make it x minus 1 with a negative on the outside, but we talked about how all that's going to do is just make this a plus. So that's the shortcut. You see 1 minus x, make it x minus 1, and then change the sign in front. In this case, we're changing the sign in front of the fraction, making it a plus. All right, so now I still need, though, I got to put this over 1 over 1. I still need a common denominator. So I have an x plus 1. I need x minus 1 here. So I need x minus 1 up here. I need x plus 1 here. So I need x plus 1 up here. Now, this is 1 over 1. You still got to get that as part of the common denominator. So you need both. You need x plus 1 here. You also need x minus 1. You need it on the bottom. You also need it on the top. So this one's a little bit different. When you see that 1 there, don't disregard it. You still got to get that common denominator. So now I have my common denominator. And I'm left with what? 3 times x minus 1 is 3x minus 3. This is a 2 times an x plus 1, so that's 2x plus 2. Equals, and this is x squared minus 1. X plus 1 times x minus 1 is x squared minus 1. I have another quadratic equation. Let's see, I have 5x minus 1 equals x squared minus 1. The minus 1s, that's, if you add 1 to both sides, you got nothing there. So this is going to be 0 equals x squared minus 5x. So now I'm going to factor x times x minus 5, and of course x equals 0 and x equals 5 at that point. Any restrictions? All my restrictions were 1 or negative 1, so I do have 2 solutions. I have 0 and 5 as solutions here. Only 1 and negative 1 were my restrictions. All right, this is an ugly one. Last example, though, we got a couple factors we have to do. We have 2x plus 4. That's that guy. This is just x minus 4. And then this guy is x plus 4x minus 4. So what do we need? Well, I have a 2 here. So I'm going to need a 2 here, which means I need it here, and I need it here, which means I need it up here. X plus 4 is here and here. It is not here. So I need in the middle here, I need an x plus 4. So up here I'm going to need an x plus 4. And I have x minus 4 here and here. I need an x minus 4 over here. Alright, so what am I left with? Well, this right here, denominators cancel out. I have x times x minus 4. So I have, let me just divide this here. X times x minus 4. I have x squared minus 4x plus 2x plus 8. And that equals 32. So I have x squared minus 2x. Remember, subtract, get it equal to 0. So I'm going to do this all together. minus 2x, this combines to minus 2x, and this combines to negative 24. Yep. And that's going to factor to x minus 6, x plus 4. Yes, it does. And that's x equals 6, x equals negative 4. But negative 4 was an original, x cannot equal negative 4. X cannot be 4, x cannot be negative 4 based on my original equation there. So we have to reject negative 4. Therefore, just 6. Just 6 is going to be the solution here. See you in class tomorrow for some more practice on these rational equations.